do with the plan view, if you draw the, if I'm going to sketch the plan view just out of curiosity, if we were to look at the plan view, right? So the plan, so if I were to look at the plan view, let me draw this properly. Right. So the plan view, if I were to draw this, so this will be our, again, this will be our Y, and this will be our X, and this will be rotation of Z, right? So it is basically, we get a view like this. And what we see, if we were to sketch, this is our element B. Over here is our element A. And we know that there's a force coming down here. And this is 20 times 10 to the power 3. And then we have a force going in this way across. That's 90 times 10 to the power 3 pounds. So what we gain from here by drawing this view, right? We only can gain to say that By is equal to 20 times 10 to the power 3 pounds, which what we had over here already. Okay, so that's why sometimes you can just do two views, right? You don't need to go up to three views. Okay, right. So this is for combined loading, and why I'm teaching this now, because it will be good for you for your term test also, to identify your moments in what directions. And this is a real 3D problem. Okay, so this course we are solving real 3D issues rather than just 2D. Okay, you can see I can give you any loading situation. Like today, these are the few most complex loading situation that you can find in any textbook or in real life. Okay, look at this. Okay, so you need to have the confidence, okay, to identify what's the torque, what's the moment, what's the axial load, and what's the shear force. Okay, right. So today I'm going to very briefly start onto shear force. Okay, I'm going to start to shearing stress. As I said before, okay, shearing stress is one of the most difficult topic in this course. Okay, in fact, it's the most difficult topic. A lot of universities, when they teach this topic, they teach very surface. Okay, but because of my understanding on this topic, we can go into depth. Okay, so introduction to shearing stress. Now, shearing stress can be generated due to can be generated in three forms. Okay, so shearing stress can be generated in three different forms. Okay, so the first one we know is either we have single shear or double shear of fasteners. So the shear stress calculated is equal to P over A for single shear. And for double shear is P over 2A, okay, for double shear. So we tend to ask ourselves, what is a single shear and what is a double shear? Okay, so now if we have two plates, Okay, or we have a bolt. Okay, so this is our bolt or fastener. And then we have a plate over here. And then we have another plate over here. Right? And this is one plate or member. So this is member number 1. And then over here, this is our member number 2. And over here, this is our fastener. And then the force that is applied is one go in this direction, and the other one goes into the other direction. Okay, so failure will occur on this red line. Okay, this is where failure will occur. And if I were to look at the cross section, this is the cross section, okay, of this point over here. And this is what we call our area, right? So that's why for single shear is P over A. Okay, so this is what we call single shear. Okay, single shear configuration. Now double shear, okay, double shear again, you have the same fastener. Okay, but now your load are applied differently, and I'll draw for you. Okay, so this is right. So this is all your members. So this is member number 1. You have your member number 2. And then you have your member number 3. And then we have our loads that's applied. So we have P. I do apologize, I should make this red. So over the other side over there, this is P over 2. So it will be at its equivalent. Okay. Now failure will now occur in 2 regions. Okay, so this is failure region, the red. This is failure region. So this is our failure region. Or failure will occur along the 2 lines. And the cross section, right, for the top, you have this cross sectional area. And at the bottom, likewise, you have another area. So that's why for double shear, right, you got 2 areas, you put a 2 down here. Okay, so that is the difference between single shear and double shear. So when we say single shear and double shear, right, we calculate the shear stress is P over A for single shear, P over 2A for double shear, and the shear is the cross-sectional area of the bolt. Okay, so that's the first one. Now the next one, the shear right, is due to torsion, like what we have mentioned before. Okay, the second one is due to torsion. And when it's due to torsion, the formula that we apply is shear is equal to TR over J. Okay, so for this case, if we look into a 3D view, right, we did a lot of this earlier, X, Y, and Z, and then this is our shaft. Okay, and then this is our geometric axis. And then what is happened is you have torque applied in one direction, right? And then you have torque going in the opposite direction. They go into the opposite direction. Okay. So for this case, we can declare that T1 is equal to T2 is equal to T. Okay. So the other one is due to torque. Okay. But we have to remember, if I draw the next case, okay, again, same structure. Okay. And then we have our axis. Now, if the torque, this is T1 and this is T2, and when T1 is equal to T2, the shear stress is equal to 0. Okay, if the magnitude and the torque are the same, right, there's no distortion. Okay, when or deformation, when it's opposite, there's deformation. So I'll give you an example, right? Your shaft will only break, your drive shaft in your car will only break, right, if you do a very if you do this, you're moving forward and all of a sudden what do, you engage your what, your reverse gear while moving forward, right? So the momentum of the car, the torque is going forward, is in one direction, and when you push reverse, right, the torque is in the opposite direction, you will break your shaft, okay, your drive shaft. Don't try it, okay? So, but when it's in the same direction of rotation, it will not break, okay? So the third type, and you guys have seen seen the equation, is due to shear force. And the formula is shear stress is equal to BQ over IT. So how does this work? So if you have a beam, okay, so this is your X and Y, this is rotation about Z. Then you have a beam, right? This is your P, and in this case, P will be equal to your Vy. Okay, so once you know your Vy, so if I write the form of this equation, so this is equal to Vy over Ixx Qx over T. So if we were to look at the cross-sectional view, so this is Y, Z, okay, this will be our rotational X, okay. The shear force will be in this direction. So this will be equal to your sorry, it should not be IZXX, it should be IZZ. Right? So we know that this is your Vy, and this axis over here Okay, this axis over here is your z axis, sorry. Okay. So when your Vy is coming in perpendicular, right, you use your Vz. Okay, right. I'm gonna stop here, right? I will see you guys on Thursday where we have our term test face to face, and then we'll continue again on this lecture on the introduction of shearing stress next week. Okay, thank you. Goodbye.